My name is Lynn Komp, and I work, ironically, also in the network platforms group. My background is interesting. I've spent most of my career in communications infrastructure, and so everything from wireless, wireline, internet deployments, etc. Although I've also spent time in cloud and enterprise, and there's a very interesting hybrid world that's been emerging over the last few years between these two environments that we'll talk a little bit more about. And please stop and ask me if you have any questions. We will do everything in our power to remove the buzzword bingo and the acronyms as much as possible, but do call me on it if it gets a little bit too much, because in high tech, what would we do if we didn't have 3-letter or 4-letter acronyms? So, as we learned today, what is network infrastructure? It's something that you can't live without, but at the same time, people tend to forget that it is there. So I have a couple funny stories. Some of the service providers that are providing services to consumers in the home have these great stories about when their customers call and ask them for help on something because they assume the network service is down. Of equipment in the home that was the problem. And so they end up supporting a lot of things that have nothing to do with the network because people always assume it's always on and always available. And so what does the network do? So I'm going to go from right to left just for a little twist. It connects between data centers, and that's a little bit esoteric. So it also links resources within a data center. Now, what does that mean? If you are logging into Facebook, you're going to go in through something that's called a web server. That's going to take your traffic, and then say you want to look at your pictures. And it depends on how old they are, what resource you're going to actually have to tie in to that session. And if the pictures are a year old, they're going to be way out on potentially something called cold storage, which would be a different part of the data center resources, maybe not as accessible as close as something that you just posted 2 days ago. And so this is why the network within the data center is so important, because the data placement is going to be affected by the timeliness and how frequently that data is accessed. Now, the one that we all know and love is it connects users and devices to services and applications. And we called this at one point the virtuous cycle. Gartner has said there's zettabytes worth of data that are being created, and it just accelerates every year. Now, many of those pieces of data have things to do with cats playing on pianos and cute little puppy videos, but it's still growing. And there's something that's referred to as uplink and downlink. It used to be that a lot of this data sharing was one direction. It was from the content owners or from the data center out to individuals, out to the endpoints as we call them. But now there's a two-way dynamic, up and downlink, that's happening where people are taking videos and instantaneously loading them online. We've got news reporters that are doing this real time, and then they're borrowing from videos that people have taken for events as they're hitting on Twitter or they're hitting on social media and becoming very popular. And that has a really big impact on the architecture and the availability of what's in the network. Very important. We're all used to being connected. I don't know if you've ever had the experience of losing access to Waze right as you were going to take that last left turn. That is why the network matters. Now, the good thing about this is it is creating these unprecedented economic opportunities. And it's not just for Intel. New internet services estimated to be about $450 billion worth of opportunity. Waze is a good example. It's my new favorite app. Cloud infrastructure, that one's probably less surprising. Everybody's been talking about Amazon and Azure. If you follow the Gartner quadrant models, you've always see the two at the top and others on different parts of the quadrant. That one's a little bit more normal. NFV revenue. I will explain this term. Now, I will catch myself on the 3-letter acronym. It means network function virtualization. It is the last step to being able to have a completely agile environment and get access to all of the resources instantaneously. And I'll explain it in a little bit. SDN. Software-defined networking. This is another area where they're seeing these leaps and bounds in the ability to have instantaneous changing network maps so that you can get those connections when you need it, where you need it, instead of waiting for new services to be deployed. And then infrastructure CapEx growth. This is basically what you spend to support the new demand, the new services, whether it's storage to support new photos and new videos or caching of content, whether it's a better network. We're seeing LTE, which is the network upgrade in the wireless world that is rolling out in the US. And we're starting to talk about 5G, which is next generation, that should be deploying starting in 2018, 2020. Lots of opportunities, lots of bandwidth growth. And it's all there to support this cycle of services and devices and content and more services, more devices, and more content. What is the network transformation? So one of the things that we're seeing, and I would imagine you're seeing as well, I mean, you have Packet Pushers Interactive here, so I'm guessing that you're very familiar with this dynamic where you have IT operators in the network world who are looking at ways to be able to manage traffic differently, use new tools. You have service providers in the communications world that want to start pulling in technologies out of the enterprise and the cloud. They want that level of agility. And then at the same time, you've got the cloud service providers, and they're all learning from one another and all starting to deploy similar technologies. Now, they're going to use them in different ways. They're potentially going to have different KPIs or SLAs, service level agreements, associated with them. But everybody is trying to deploy similar things together. And please, do stop me, ask if you have questions, comments. Don't feel like it can't be interactive, even if there are people watching on the video. Now, why does Intel care about this? You guys probably have heard that Intel's in the cloud, Intel's in the data center, Intel's in the PCs. We've been in the network for a very long time, and we do things from inside the data center all the way out to the edge. Now, inside the data center, something that we would call the fabric that you would see very often would be something like Ethernet. Very familiar. It tends to be higher speeds than what you would see in your house, but networking solutions, Ethernet in the data center. And then we have router core and backbone. Those are fancy terms for all of the stuff, the base stations. You've got as Sandra Rivera puts it, she's my boss, she calls them the ugly trees. They're the ones with the extra cell towers that you'll see up and down the highways. There's core and router, which you'll also see, maybe not as much. Central offices will have some of these deployed out in the distributed arena. And then you've got the small cells and the macro base stations. The macro base stations are actually the ugly trees. They've also got small cells, which are smaller versions of these, and they're a little harder to spot. Sometimes they look like a little Wi-Fi base station stuck on the side of a building. And Intel is providing solutions all the way through, end to end. Now, how many of you were at the developer forum? Anyone there? No? Well, first thing you should go do is take a look at some of the IoT capabilities, Internet of Things capabilities. So all of these 50 billion of devices that could be deployed, there are some examples there. They had robots, little spider robots that were wirelessly connected. They had connected cars, there's connected bracelets, there's connected glasses. All of these things are what are going to be the next wave of things hitting this network and generating different levels of data, different levels of demand. So there's a lot of videos on that might be interesting to go take a look at. Now, what is Intel doing? Now, the thing that's really important is that in the network communications service provider, traditional comms, they are starting to look at the way that cloud has emerged in enterprises and realized we could really benefit from things like virtualization. We could really benefit from some of the management tools. We could very much benefit from the power and the security innovations that have come out. And most of them have deployed already in the data center itself. And so Intel is now working to apply Moore's Law, should be no surprise there, network function virtualization, which takes advantage of virtualization technologies that you would see in the data center and applies them to network functions. And then SDN. So there's a network agility challenge that we're working to address by taking everything that we've learned from the data center and the cloud environments that we've been participating in for years, working with service providers so that they can get the benefits of the agility, the efficiency, and the management capabilities, the remote management capabilities that many data center managers have already been using in the recent years. Now, software-defined infrastructure hopefully is familiar. It's been discussed a lot in the industry. You've seen things about software-defined data center, software-defined infrastructure, software-defined networking. Really what this means is you're working with standardized platforms that are standard high volume, and then you're creating pools of resources, standardized software, and being able to deploy different functions as you need them, where you need them, throughout a data center environment. And so this is made possible by orchestration software. Now, I've had many people say, what is an orchestrator? Because it's one of the current favorite words. It's really just the next version of the unified management vision that many data center people have had for years. I won't say one pane of glass, but it is getting closer to the ability to have that vision realized, both in the network as well as in the data center. Now, one thing that I did want to bring up as it results and relates to software-defined infrastructure is we just announced an initiative called Cloud for All. And this has really got three vectors. We're focused on investing so that the enterprise and the data centers, the private clouds, can pull in many of the innovations of the hyperscale clouds without having to try and compete for the PhDs and all of the computer science talent that those hyperscale clouds attract. The enterprises would love to be able to go ahead and deploy those kinds of functions, but the hyperscale cloud vendors are really not creating standalone products for someone else to deploy in their data centers. They're building these solutions for their own use in their own environment. And so the investment pillar for this initiative is really focused on accelerating open standards and open source projects to the point where they're hardened, working with companies such as Rackspace and others to make sure that there's somebody that will pick up the phone and answer questions, very important in an enterprise data center. And then they can get these easy to deploy SDI solutions, but it's in an off-the-shelf form. They're not going to have to build everything themselves. The next pillar is optimizations. So high efficiency clouds across workloads. It can be really difficult if you're trying to do cloud-aware applications or hyperscale cloud applications. Most of these developers don't have 1,000 node clusters at their beck and call. And it's very difficult to do that kind of application design and test if you have nothing that you can actually run it on until it goes live on somebody's cloud and you're hosting it there. And so one of the areas that we're working on is setting up these clusters and making them available for the developer community. So people who are trying to drive and develop these cloud-aware apps that are distributed across multiple locations and have some latency things that they might want to manage, they have the ability to access it and remote in through this infrastructure that we're investing in to make it more possible for these developers to really tighten up on user experience when they do go live. The last thing is aligning the industry to accelerate cloud deployments, working with our partners, working with commercialized vendors who have an incentive and want to help accelerate this business. So there's a lot of partners that you'll see in the announcement. I don't actually have the logo wall, but I know Barbara and others can go ahead and share that with you. Now, related to this is the underlying network. One of the things that I keep hearing or kept hearing when I was in the data center business from many CIOs is, it's great that I can set up a compute instance in minutes. We've gotten virtualization down. I can get an application server in 6 minutes. The problem is I can't actually get my network security policy applied because I'm still in hardware. So I can set up an application server in a minute, but it takes me about 6 to 8 weeks to procure the gear that I need to put next to that application space so that my network security protocols and policies aren't broken. And then I have to figure out where am I going to plug it in. Now, that problem statement is why network function virtualization. And it really comes down to being able to run that same network function, firewalls, VPNs, load balancing, that you would normally see in a hardware appliance, but being able to spin it up instantaneously in support of the application so that that whole network security protocol, the policies are all applied. But it can be as instantaneous as getting the application server available to the developers. So that is one instance, and it's built on standard data center architecture. It's built on virtualization. It's built on many of the Intel VT technologies that have been out and mature in the market for many years. And so we've got a number of innovations, the IA processor. There's a lot of support. NIC is really our Ethernet product line. There's a lot of offload and hooks in support of virtualization in those products as well. Acceleration in the chipset, switch silicon, and investments in open software. So this is really a transition that both the data center side of the networking world as well as the communications service provider world are really going all in on. They're very invested in it because it gives them agility. There's a lot of people who talk about CapEx benefits and TCO, and that is in there as well. But when you're dealing with this problem of being able to give instant services to people with your infrastructure, it's much more about the agility and the efficiency and unlocking everything that's in your infrastructure instead of having locked up resources that you really cannot deploy and leverage. Now, the reason I asked about IDF is we also did an announcement related to the network while we were there yesterday. And we're calling it the Network Builder's FastTrack, because what we're also finding in this market is that they're going through their own maturity curve. And so there's 3 pillars. Innovation and solution stack delivery. We want to make sure that the whole ecosystem has the ability and the training necessary to be able to take advantage of the innovations that are in the platform and leverage them in the most efficient manner possible. What we're finding is there's a lot of features in the platforms that can benefit these I/O workloads, and they're not getting used as efficiently as the companies we work with have an opportunity. So that's one piece. Integrate. We're starting to work much more deliberately with systems integrators and the people who really stand these solutions up and make sure that they have collaboratively with us solutions blueprints. And these blueprints, especially in the communication service provider world in telco, they are the Bible of how everything gets deployed. It's not just a 2-page white paper that suggests how things could be integrated. These are actually running solutions that we would plan to put in place, both with lighthouse service providers as well as with systems integrators, so then they can go replicate it and accelerate the deployment in the industry. Now, the third thing is this optimizations. Now, one of the areas that we found, if you are in this network world, especially in communication service providers, they have been watching the enterprise and the data center ecosystem for many years saying, why can't I have an ecosystem like that? I want best of breed components. I want to be able to mix and match. I want to be able to have a unified management scheme that I can choose vendor A for a specific function in software and vendor B's hardware. I don't want it from all in one place. But that journey requires them to do a little bit more when you're talking about interoperability. If you've been in any IEEE environment, PCIe is another one where pluck fests and hackathons are sort of like breathing. If you ask somebody who's in a PCIe group, do you do plug fest? It's sort of asking a fish what water are they swimming in. It is not something that has been completely institutionalized in this market. So we're starting to work with third-party testing and interoperability labs. And we have some already in place, and we're going to start doing more so that all of these software and hardware vendors that are bringing best-of-breed components into this new world can work together and make sure they've got everything tightened down, interoperable, completely compliant, and they're meeting all of the SLAs that are required for that specific solution space. Yes.
happening on the field of benchmarking in that area as well?
Yes, that is actually another thing that is a new methodology, is industry standard benchmarking. You're going from an environment where you end up having a very specific test model on a very specific traffic model, and then moving to something that's more TPC and spec-like. But that synthetic benchmarking capability is really, really important to have somebody get a basic rule of thumb of where one solution stands relative to another in a very quick and efficient manner. So there's going to be a lot more in something called OPNFV, which conveniently I went to the standards page. We've been doing a lot of work with the industry in terms of open standardization. Now, we started out very much focused on open code, open source. Very similar to where enterprise started doing in its journey when we started creating things like NoSQL. Didn't exist before, and now it's an industry standard. We're on that journey in communications and networking. So, specific to the benchmarking, OPNFV, this open platform for NFV, has a test and characterization work group that we're going to increase our contributions to, so that there's a start point that's more existing code from multiple vendors, so that those vendors are able to then more accelerate the interoperability and the benchmarking and testing. So it's something we've already been working on, but this initiative that I just referred to, the FastTrack, is really focused on making it faster, obvious from the name. And with that, very quickly, to reiterate, recap, network is in everything. Network is part of making everything work that we're used to. It's part of the connectivity for being able to write a report and upload it immediately, no more phone calls. It's part of being able to load videos and pictures, everything that would be necessary for many industries.